I'll try to bang through a little bit of the beginning slides pretty quickly so that we can get to some of the little more fun stuff at the end. A little bit about myself, a presentation, a little intro, our case study. We'll show you the Steam controller automation system. We'll talk a little bit about the development and operations of it, and then talk a little bit about some of the stories afterwards, and then maybe have a little time at the end for some lightning round as well. Background on me, you can read about work for the companies up in the Northwest, started in aerospace, worked my way into supply chain and manufacturing at Microsoft for the first couple of generations of Xboxes, ran operations on 3 continents for mechanical manufacturing, got to work on all kinds of products, launched things that went to Mars, thermal test systems, a lot of Xboxes, got into wearables. We developed, when I was at Synapse, we did a lot of product development for Nike, so I've worked kind of full scale from the time that the client walks in the door and says, here's our sketch and concept, to all the way to building the factory and shutting it down and putting it away, and then doing it again. I'm going to show you a little video here. This is the video online that Valve made for the Steam controller manufacturing system, and this is our automation, our site, so let's watch this for a couple minutes. So one, pretty cool that Valve actually made the video and actually put it out there to show and share. That I'm definitely appreciative of, because you don't get a chance to show and talk about what you work on inside the factory walls sometimes. Perhaps afterwards, I'd love to hear if anybody's worked on something like this, because I feel from what I've been told, it's a pretty unique situation that we had there, and a pretty ambitious project that we took on. So I just want to break it down just a little bit so you have a bit of an idea of what you just saw. This site is a Flextronics site outside of Chicago. It's about this space that we're in, about 44,000 square feet. First thing you don't really see too much is there was 2 products being done there. So there was an automation line on the side for the Steam Link line, and that was kind of hiding back there. Steam Link was a little streaming box they used to stream PC content to your TV screen. It was a simple product to assemble, so it was really just 2 assembly stations screwing things together and 2 test stations, and it had a really high build rate, and we just packed it out manually. Originally, we wanted to have both products filter in together to our packaging line and have essentially 2 products go into no-touch assembly and pack. The rest of the stuff you see is basically space dedicated to the Steam controller. That was the Steam controller. What you see in that previous picture is about 60% of the equipment, so there's a whole bunch off to the right that you just don't see. This was all doing no-touch assembly for that device outside of the circuit board. So 2 really high-end automated functional test stations and a web of 13 different assembly stations, just putting parts, sub-assemblies together, sub-assemblies until it all gets together and then fully integrated into the boxes with pretty much nobody touching them in between. There's kind of the red stuff, everything you saw was all packaging related. A lot of other stuff that obviously goes into building a product and getting it all together. So PCBAs came in, we had 3 or 4 PCBA lines in Asia. They're nice and dense, we could get them all packed in, made it efficient, and those we had shipped in trays. We had an injection molding site right next to this facility, which had about 25 presses, and every press had an automated material handling system that trays everything for use. Another molding site with about 5 presses that were doing 2-shot buttons and kitting. So you have a press do all the green buttons, all the blue buttons, all the red buttons, and then stick it into an automated line that mixed them so you had red, blue, green, red, blue, green, red, blue, green. So simple things like that, using automation sometimes makes it pretty complicated, but things you need to do if you don't want to involve a lot of touch and labor on repetitive actions. So, that was the system at a high level, and some of the things I just want to share just throughout the development and installation of this product. And part of the reason why, when I was talking with Anna, she said, you need to come talk about this. It was a cool project, yeah, but it was really hard because it was essentially simultaneous development of 2 products, the link and the controller, 2 automation lines, and basically we went into an empty factory where we had to hire staff, build new processes and procedures, and help coach the folks to operate that equipment. So a lot of times, also we basically had 1 team at Valve, and I think saying that we had 20 people working on this is pretty generous. And 2 main partners, basically our contract manufacturer and our automation developing partners, obviously with much larger teams than we had. I felt, you hear this analogy about startups all the time, and this is the only thing I could always think of. It feels like this, but like twice as hard or squared. It's like, how do you build the factory while you're building the automation, while you're building the product at the same time? There's things in there that intrinsically don't work. So what I really want to talk about and share and tell you all the stories about later tonight are just some of these lessons that we learned in fairly hard ways, but some of my high-level observations about working with highly automated systems, that when I looked at it, it's a supply chain problem. In working with getting, whether it's materials across the world into your factory, or whether it's getting a part positioned exactly right in a nest for operations, you're moving material, and it's a supply chain problem that you have to pay attention to at the macro level and the micro level, all the way until the instant your parts and your material is about to be operated on. And it's not trivial, because when I talk about the molding facility that had to have, every press had to have an automation system, the automation system next to every injection molding press was bigger than the press, and would probably have 3 or 4 different handling points to get parts off the tool. The tool has its own pitch, get it set on a tray, and get it into the trays that eventually get delivered, and you see them stacked up, to get it delivered into the magazine holders that held all the trays, so then the robots know where the parts are every time they go to pick. There's no vision system, it's all programmed, so everything has to be in its right spot. So that's kind of the mother of the micro supply chain issue to go solve. Every assembly operation is critical, none are trivial, and I'll talk a little bit more about this later in the presentation. Some might just work, and that's great, and you don't need to spend any more time on them. You got to go on to solve your Pareto of big issues, but you can't take any single step for granted. And kind of like Andre's, like, what happened in the process when something breaks? You got to go find it, because something that was working just fine yesterday, or for the million units before this, changed. And when there's 5,000 operations that have to happen, you got to go find that one. And also with major big automation, essentially every operation or every step in the process is a test of the product, the material, or the equipment at some level or another. Again, every step you could take for granted. The robot picks up this and moves it there. It did it all day long for 5 million pieces last week, but something changed in the process and the robot can't grab it anymore, and you got to figure out what changed. So aside from these really fancy functional test systems that you might have at the end of your system, just the trivial act of moving something from here to here can break, and automation is really good at finding that, because automation is not intelligent. It will do the same thing all day long, and it'll do it really, really consistently. But it's up to us to go figure out, is it doing it consistently in the way that yields a good product? And that's really the trick. And so that's where having systems that can utilize data and chart and plot, there's important data. Michele had some really good points about how to build a system and analytics. We did take the approach of, we need to collect as much data as possible, because we don't know enough about the product. I mean, knowing how your product goes together and works is a challenge on itself, but then knowing how this complex machinery works is its own challenge in itself. And so it was valuable to us to collect a lot of data and then be able to go back in time and test it for certain correlations, or test it for certain things that we would discover over time if we had it. And so we sometimes have that opportunity to do it. It doesn't necessarily help you get a good product out the factory if you find something that is a real issue, but there's a lot of things you just didn't know. So we'd rather err on the side of having the data. Building a system to collect the right data is always really powerful from the beginning as well. And there you go, the data is gold. So the really question about the system is, like, what kind of solution did we have for collecting it and managing it and creating operational metrics to know that it was working right and we're producing good products. I'll come back to that, but I'll tell you a little bit about the NPI. So we had product development was just hard in general. Our team was in Seattle, our automation partner was in Nashville, and the test equipment was made in Greenville. So we're diverse across the country, and we chose to do this in the U.S. because things are close to each other. But every time you get on an airplane across the country, it's still taking your team away from development activities, and again, with a small team, we're doing everything. We're doing operations, we're doing legal, we're doing marketing, we're doing sales preparation, we're doing the engineering, the product development, the operations, the supply chain, all in that 20 people. So if they're out developing NPI, doing NPI on the automation, they're not doing something else. And so we work with our contract manufacturer to basically build the system from scratch. And this is where I wish I'd known Instrumental or other folks that had these types of capabilities. I would say that they probably existed, but wasn't something that we could shoehorn in. And so the data collection and management was just the stepchild project that had to be done. Guess who got to do it? This was just like one of my side projects on a day-to-day basis. So we wrote the requirements. We worked with a contract manufacturer that had a team of database folks that could integrate with our folks in Nashville that were building the system. And it was, I say it was painful. It was definitely painful for me, but it was hard. So yeah, we had the NPI there to get just the information off the dial. So, sorry, the automation stations, we call them dials because they're round and each one had a number of stations. We basically would have to fly out to Nashville, decide we're going to go be there for a week while we're having runs staged, and run from PLC to PLC to suck the data with USB sticks onto our machines. And then after the day was over, we'd go back to the hotel, sit in the restaurant, and tear apart parts on the table and correlate it to data we saw on spreadsheets and things like that. So we were doing this in an extremely manual way. There was nothing remote. We were building, take the logging tools from the test stations, building parsing tools, sticking them into spreadsheets, slicing and dicing, and it was horrible. There's just no other way to say it. And we could only really focus on like one station at a time, and we kind of knew that this automation system it's an integrated system. Something at test at the end of the station is, if it fails there, it's going to fail because of something that happened 15 steps earlier, and we just didn't have all those correlations and that just knowledge built to figure it out. So we're really siloed and focused on solving very specific issues for very specific stations, and knowing that I don't know if what I'm focused on is really going to fix the situation and get our yields up and get the machine running at the metrics that we needed to run. So it just wasn't really the right way to do this. So we just didn't have this really integrated system for NPI, let alone getting it ready for manufacturing. It would have been great to have some kind of really lightweight system that could come in and give us a dashboard. I know a lot of these large enterprise level type integrations aren't trivial and easy, but being able to get at least some key information off the machines, automated, up into a dashboard, and at least able to start slicing and dicing would have been really helpful. So we hired the team. Some of the challenges is that the contract manufacturing team, they know their tools, they know their manufacturing processes, they know what they do on a day-to-day basis. This was not the typical thing that they do every day. Here, please come take our multi-million-dollar automation system, dump it in your factory, and you figure out how to plumb and hook it up. Those aren't people that sit around there on a day and maintain it for the next 2 or 3 years. Those aren't people that are normally set there. So I say they weren't capable. It just wasn't their everyday capability. Like, where does this team of people exist? It doesn't really exist at the CM. And how do you manage this? And so there are systems and databases that are made, but we're collecting over 100,000 data points instrumented across that line. And you don't need every single one of them to produce your product. And a lot of them are very trivial. The robot moved from here to here, but a lot of those are really important. So you need access to them. You need to figure out which ones they are. And not an easy problem to go develop and figure out in time for hitting the launch time frame. So we basically worked with them and staffed a team and created a highly customized data collection system that was it's entirely its own thing. And when you're doing this, again, with a team of folks of 5, 6, 7 folks that don't do this every day, how do you know that testing this and every station, the data you're getting back is validated and working? It was again, really difficult. So being able to use a tool or system that's kind of already been used and debugged is incredibly valuable. And also working with contract manufacturers, everything that goes on technically within the walls of their facility, to a degree, belongs to them. And so we had to have a lot of discussion on how to get the information from the automation system passed from them to us, so that we didn't have to get on the airplane every week to go just see what the metrics were doing. I mean, we have a sustaining team that couldn't live at the factory. Some of us did for months, but how do you manage that? It was really difficult for us, and so we just didn't have the right level of expertise, but we built something. So again, the real time, these are all the problems and all the things that we struggled with. So at the end of it, we did the production run. We kept that system in operation for about 2 years, and it was more efficient for us to just build it out, store the product, and then mothball. But we had new products that we wanted to get to and develop, and so we did a really deep lessons learned, and you can imagine there's a lot of lessons learned when you go through building a system and a product like that. And so we said, well, we're not going to repeat some of those issues, but so we put the factory away, we took our equipment, we retooled it, we said we're going to still automate, we still are invested in, one, literally invested in equipment, and two, literally invested in the idea of automation. And we're going to do some of our process, but we're going to do it the right way. So we did start with a new greenfield site and a new team of folks for the new products, and did our best. We did a pretty good job, I believe, at learning from what worked well and what didn't work well with developing the automation. Tons to talk about there on its own. But we built another ground-up data collection system. And there wasn't like, hey, we have a charting system, but we need to plug it in. And that development, again, it's really hard. And so that was the one that I wish there was just a really good solution, and I think a place where someone like Instrumental can help folks get off the ground quickly without a lot of the pain that we experienced. And also just the amount of time you had. We didn't have data collection again until after we launched, and so that's kind of crazy. So, some of these big takeaways that why did we do this massive automation system? We were bought into this idea, and it was something that fundamentally wasn't tested. And I think that one of the real lessons for anybody that's really interested in getting into automation is, don't throw the Hail Mary. Sneak up on it. Don't guess. Don't assume it's going to work. There's so many assumptions about your market and your product and the volumes that need to be figured out. Again, Michele was really focused on the ROIs, and you need to make sure that you've done these product iterations a few times. Unless you're someone like Apple, right, who's just churning out. It's got generation and generation and generation for high volume. They can tell you to 0.1% how many units they're going to build and what market influences influence their volume. That's the right time. When you're getting to that area, that's the right time to really be doing this. Definitely focus on the stations and the constraints. There's a great idea of constraints and where's my biggest problem, and it doesn't always have to be a constraint in the process or the management process or the development process, but the problems that are constraining you from a literal operation and engineering standpoint are great places to go focus and test this one little thing. And make sure that when you go do this, that you're going to get the right ROI out of them. And just a lot of this really needs to be driven. I have a strong fundamental that these large changes or shifts in the contract manufacturing relationships, whether you own your own factory or working with CMs, you need to have that vision. The contract manufacturers, you can have great partners across the supply chain, but their incentives are to build the product at the end of the day. And as the OEM, someone was mentioning, when something happens, who's really responsible at the end of the day? You could have contracts and paperwork that say you're responsible for this, you're responsible for that, you're responsible for that. At the end of the day, it's your brand, it's your product, it's your rating on Amazon that suffers. So to be able to drive the optimizations or any of the performances that you want to incentivize from your manufacturing operations, you need to do that as the product owner and as the OEM. And hopefully you get a system that just gets data into the cloud as quickly as possible, because this is the next greatest thing for manufacturing. Get your data outside of the factory wall. Don't deal with, get it outside of these IP issues, or get that negotiated in. And as soon as you're in the cloud, the infrastructure that exists today is so much greater and so much more powerful. And the tools are so much better, and that's one of the great trends that I see happening today. And again, Instrumental taking a big leadership portion in that. If you can use an off-the-shelf type product, listing databases, charting, that's great. Just don't buy the new every time. I can tell you, it's a lot of work, it's a lot of expense. It's probably not your core competency. It's probably not your contract manufacturer's core competency to developing these. Find good partners and work with them. Okay, that was, I think, most of the. Do you have a little bit more time, or no? Okay. We'll talk about this stuff later. This is when you want to talk about what things are easy in automation and what things are hard. Everyone's talked about it before. So anyway, I'll let the next person go, and thank you guys very much.